All right, how about this one? Let's find the N, V, and M at point C, and there's no D, so let's do it at point C. All right, this is going to be an easy one. Now, generally, yes, I do tell you to look at the whole free body diagram, and yes, I could do that, and I could solve for an AX, an AY, an MA, but the more these you do, the more comfortable you are with these. Thinking ahead, what if I cut it and kept this half of it? I'm going to throw away that half. There are no unknowns over here. So this time I'm going to skip the whole free body diagram, and I'm just going to cut it right here and keep this side. So let me cut it right here and keep this side. So I've got, let me be careful there. This is kind of right here. 40 kilonewtons at 60 degrees. I have this rectangular and then triangular. Let me go ahead and replace this rectangular one with, a 24 kilonewton, and this triangular one. All right, so this is going to be 24 kilonewtons, 1.5 and 1.5. And then this one is going to be, 1/2 base times height, 12 kilonewtons, 1 from there, 2 from there. And then this is 0.3 from there. All right. But anyway, we need to draw the N, V, and M, right? That's positive sign convention, correct? And so now I can sum the forces in X. Negative N. Why did I say negative N? Because, yes, it's a positive sign convention, but these next three equations are my equilibrium equations, and these are according to my axes. These are according to whatever axes you want. So it's kind of separate that from your positive sign convention. So anyway, this is N to the left, negative, and this is 40 cosine 30. Set that equal to 0, so the math would give me a negative 20. And so I'm leaving it at that, right? That negative means compression, all right? That negative means it was right there. Now, you don't have to go back and redraw. I'm not going back and looking at your figure, all right? Now, let's sum the forces in the y direction. V is pointed up, negative 24, negative 12, negative, a lot of this 40 sine 60 equals 0. So V would be 70.7. And then summing the moments, I like to sum the moments about the cut. Summing the moments about the cut. N goes straight through the cut, V goes straight through the cut, and I've got that negative M because I want to choose positive is counterclockwise, and this M is clockwise. And then 24 times 1.5, creating a negative moment. Also 12 times, 3, 4, creating a negative moment. This goes straight through the cut, but 40 sine 60 is acting a distance of 6, and don't forget that 0.3, 6.3 away, creating a negative. Set that equal to 0, and I would get my internal moment, negative 302.2 kilonewton meters. Gotta have units on all your answers, and all the forces were kilonewtons, all the distances were in meters. So here I got away with solving for AX, AY, and MA. But if I was to keep it, if I was to cut it and wanted to keep this side, then yes, I would have to look at the whole free body diagram, solve for AX, AY, and MA. Then I could cut it and keep this left side. But I bet you we would get those three exact same answers. Negative 20, positive 70.7, and negative 302.2.